And next one on the stage is Max Hampshire. So here you go.
Where's the, there it is, brilliant. Thank you. Hi everyone. Oh, bit sensitive that. There we go. So hi, I'm Max. I'm the Developer Relations Officer for NIM. And what I'm going to be talking about today are anonymous credentials on the blockchain. So I'm going to be talking about our Coconut credentialing system and our Nix smart contract platform. Now, if people have heard about NIM before, then most of our communications recently have been very much focused on our Mixnet. So I am going to go over that in this talk as well, and then I will talk about the credentials and the blockchain very much kind of in context of excuse me, what they do to actually support this Mixnet, as well as the kind of fun application level stuff that you can build on top of it. So, what's our Mixnet? The Mixnet is a multi-purpose Mixnet. Basically, it provides network-level anonymity for any kind of network communications. And the way that we built it, it prevents traffic analysis by adversaries like the NSA, which is something that existing privacy solutions such as Tor are maybe a little bit weaker against. I'm also going to talk about, like I said, Coconut. Coconut, on the surface of it, basically just allows third-party apps to anonymize any arbitrary key value pairs. So quite similar to what was just discussed with SSIs, we can basically have stuff like users dictating whether they actually reveal part or all of a credential that allows them to do something. And then finally, I'm going to talk about Nix, which is our blockchain. And basically, Nix is our Cosmos chain that we've been using to host our CosmWasm smart contracts that have been keeping track of both the NIM token as well as looking at the rewarding system of our Mixnet over the past year, the testnets we've iterated through, and now the mainnet that we launched last night. Before I jump into those, I think I'll talk about the justification for why NIM actually exists. And it comes from this basic premise that the internet, as we currently have it, is broken. The internet wasn't made with privacy in mind. We've had privacy features kind of bolted on in a relatively ad hoc way over the last couple of decades. But none of these solutions can basically defend against the kind of global passive adversary that stuff like the Snowden leaks showed were monitoring the internet. Metadata is leaking, even if you're using something like Signal or a private, privacy-preserving cryptocurrencies like Zcash, you're still leaking metadata as to, when you're sending transactions, what your IP address is, and all of this can be used to de-anonymize you. VPNs and DVPNs essentially move the necessity of trust from you to them, and like I said, even Tor can't actually defend against adversaries that can monitor the inputs and outputs of the entire network. However, Tor and Signal and the increasing popularity of them since Snowden basically shows that there is actually a massive demand for privacy. But both Tor and Signal, and this has become really apparent during COVID, really relied on a lot of public donations. That kind of has dropped off in the last couple of years, when really that kind of funding should have been scaling. So our solution is the first of its kind in that it's the first incentivized Mixnet that we know of. Other Mixnets have existed, MixMinion being probably the most famous of them, probably the one that Satoshi, whoever they or the multiples of they were using to send emails into the mailing list that we all know and love. And yeah, the Mixnet, like I've said, I'll skip that. The first network component. So how does the Mixnet actually provide this metadata protection and data anonymity? Much like Tor, when you route traffic through the Mixnet, it's multiply encrypted and it goes through multiple hops. What this does is it unlinks the origin of the message and the destination. Each of the mix nodes, as well as the clients that are communicating with the NIM network, however, also push cover traffic, right? So dummy traffic into the Mixnet and are constantly passing it between them. One thing I should also note, when your data leaves a NIM client, it's encrypted in the Sphinx packet format. So it's the same packet format that Lightning uses. And it's chopped up into identically sized packets as well. So now, if we're looking at the traffic, what we actually see are identically sized, identically encrypted packets that are also hidden in the crowd of kind of dummy traffic that's being sent around. So you can already see, just from these steps, something like traffic analysis attacks become almost impossible to perform. On top of that, as data moves through the Mixnet, there's a variable timing delay that each packet that is applied to each packet before it makes one of these hops. Again, as soon as you have now a crowd of identically sized, identically encrypted packets, all of which may or may not actually be being fired in order, stuff like traffic analysis attacks becomes almost impossible. And the scalability of the Mixnet is something that has become very important and is also something that the incentivization that we have with the NIM token, which is the utility token kind of powering the network, allows for. So Tor, at the moment, has about 6,000 nodes. It's had 6,000 nodes for a while, and it will probably have 5,000 or 6,000 nodes for quite a long time. However, you don't always need that many nodes mixing traffic, depending on how much demand there actually is for the network. So we're actually able to scale and shrink, more importantly, the network as required. And here is a kind of a high-level comparison of the kind of network stuff that you can see if you're able to observe from a user to a service or a user to a user with these different networks. So with a VPN, you can still see traffic coming out. There's no timing delays. There's no, the size of packets can also give a lot away about what that data might actually be referring to, and then used to de-anonymize you. Similarly with Tor, packets can also be de-anonymized like this. Whereas with NIM, if you're actually able to observe the network, all you're seeing is identically sized, identically encrypted packets flying around. There's not that much you can start to infer from what the relationships between the user and a service or a user and a user might be. And yeah, this is just a slightly more detailed explanation there. So now the Mixnet's, now I've kind of gone over the Mixnet, let's dig into the maybe more Cosmos related side of this. And this is also stuff that we haven't really been talking about too much publicly yet, so I'm excited to share it all with you. So what are coconut credentials? It's basically our cryptographic signature scheme that produces privacy-enhanced credentials. And users basically will pay NIM tokens to our validator set to create these credentials for them. The kind of conceptual change that we think is really, really important to highlight with this is it shifts the question of authentication with the credential. And by credential, you could also think of something as simple as like a JavaScript web token, as a contrast maybe. Instead of asking who a user is, when you want to log into GitHub, it wants to know that you're you. With a coconut credential, it shifts that question to, does this person who actually has this credential have the right to take the action they're asking? Does this person have the right to log into this GitHub account, this email address, take part in this KYC? The way that credentials are actually created, so they're blind signed. And what that means is that if I approach our validators, I ask them to create a credential for me. Instead of saying, hi, I'm Max, could you make me a credential that would allow me to log into GitHub? What I would actually provide them with is a zero-knowledge proof that I am actually able to take this action, so they don't know what it is that they're signing. So even the validators are not actually able to start de-anonymizing the people who are asking them to make the credentials for them. They're also re-randomizable. And what this means is that if I produced a credential for someone that, for instance, had the same identifier, if that was used over a period of time, you might be able to start to de-anonymize the person who was using it because again, it's leaking metadata. Maybe you can see what time they're always using this credential or what IP address it's coming from, something like this. Re-randomizability means that you can reuse the same credential, but the people who you're presenting it to are never able to make a link between the first or 50th time you might actually be presenting the same credential to them. The actual generation of these credentials as well is split between our validator set. So each one of them will only be producing a fraction of a single credential that they're blind signing. That's also re-randomizable. So again, as these characteristics pile up, you can see that we're really starting to break a lot of the potential for de-anonymization with their use. And yeah, like I said before, they're selective disclosure credentials. The example that came up before with checked, with if you're having to prove that you're over 18, then yeah, all you have to do is prove that you're over 18. You don't actually have to say how old you are, nor do you have to show, where your ID is from or anything else about you. And the final thing I want to highlight about them is that they're ultimately it's a very generic credentialing scheme. And what I mean by that is that even though they originate from our validator set, they can actually be used for essentially any application that require a login, an authentication, or some kind of proof. So I've been using the example of logging into GitHub, but you could also think of proving that you've paid for a VPN service as a way of logging in, as opposed to providing your credit card details, your password, your username, or anything else that requires a proof. The current status of our Coconut credentials are we have implementations in both Go and Rust. These implementations are interoperable between each other. We are currently working on modularizing this code and turning it into a Cosmos module, which means that all Cosmos SDK chains can utilize it. But the code is in a usable state right now. It just will become a lot easier to integrate in the immediate future. That said, if you do want to start getting, go ahead building with it, reach out to me, and I can talk about how that might be made possible for you. I've touched upon a few use cases when I've been quickly going over what the different aspects of credentials kind of allow you to do with them. But some of the important ones that I want to highlight are, obviously, over the past 2 years, there has been an increased amount of surveillance just because of needing to constantly present either vaccine passports and there has also been a lot more kind of scrutiny, crossing borders, going into places, all of this. So we actually built a proof of concept of using Coconut credentials to create a privacy-preserving COVID passport, which basically, instead of me showing a COVID passport that, as well as my vaccination status, would say, who I am, where I'm from, all of this, all it does is it shows that this person actually has the right to cross these borders because they are operating within accordance to, for instance, like Schengen COVID travel laws, right? But you could use a Coconut credential as a replacement for essentially any kind of DID or ID system. Privacy-preserving KYC, also another example that came up in the previous talk. This is something that a lot of people who are both people who are developing applications wanting to actually have KYCs is creating a lot of overhead for them to have to, for instance, make sure that they don't distribute anything to Americans or airdrop anything to people from certain jurisdictions. You can basically then instead run your KYC through a process of people have to present these credentials that someone else has showed that they don't fall foul of any of the rules that you're not allowed to do. But you can apply this to currencies, data access, both like database access, but anything else, voting, all of this. One of the things that is a little bit further in the future, but I think something that could then actually be incredible for the ecosystem, to bring it back to Cosmos in general, is that we are a Cosmos SDK chain, we are IBC enabled, but we need to work out how to tackle passing Coconut credentials between IBC enabled chains, how you could maybe generate one from the osmosis side, all of this. And within Cosmos, this is just to kind of aid interoperability within the ecosystem and kind of boost everyone up. But when you're looking at chains like Ethereum, the actual crypto that goes on underneath the creation and the use of Coconut credentials is unrealistically expensive to run. I believe someone in our team, out of interest, did try and do Coconut credential generation on Ethereum, and it's over the block gas limit. So kind of impossible to use at that point. And once we've kind of done that, we could start getting Coconut everywhere else. So maybe we could get Coconut bridges on the horizon. That then leads me into the third kind of main network component that NIM has, and that's our Nix blockchain. The reason that we called it Nix was because the Mixnet network is called NIM. The blockchain was kind of becoming increasingly prevalent, and we wanted to just disintermediate the two and make it a little bit less confusing. Also, Nix is one of the names for the Greek deity of night, and it's just cool. So what is Nix? Nix is a fairly standard Cosmos SDK chain, IBC enabled, and we also have the ability to upload and host CosmWasm smart contracts on there. And the reason that we've maybe been a little bit quiet about that up until recently is that a CosmWasm smart contract has actually been the thing that's been keeping track of thousands, and by thousands, I think our previous testnet had over 6,000 mix nodes. So thousands of mix nodes, gateways, stake delegators, all of the currency rewarding system, and everything that went on between those people. And we've been kind of keeping this quite low-key just to see how it would work, but it's worked flawlessly through all of these mix nets. So it has it's scalable and has a massive throughput, and is also incredibly reliable. The reason that we're also presenting Nix like this now is that we've decided to allow anyone to actually upload smart contracts and use Coconut on our chain. So we've basically decided to make Nix a kind of an open smart contracting platform that people can then join the NIM ecosystem on the application level with CosmWasm smart contracts if they want to build like that. So why? Why would you use Nix? One of the earliest talks today was, talking about really discussing like the plurality of chains that we have in the Cosmos ecosystem, the ability to even kind of upload apps and then rely on the validator sets of the main Cosmos hub. So with all of this possibility there, why would you decide to host your application on Nix? The first reason is the network security. We have a very, very good validator set. We have very strong network incentives for the investors behind NIM to keep this chain running and keep it secure. The second reason is that even though I've kind of just talked about our plans to modularize and maybe bridge Coconut, it is going to be debuted on Nix. All the new features will be rolling out there. And so anyone who's really keen to kind of start immediately accessing it it's a good place to be for that. And finally, the kind of privacy community that we want to start building. Nix is the home of the smart contracts running the Mixnet, and privacy-preserving apps will be in good company there. They'll also be able to utilize having NIM as a base currency if they want to use that as well, and just take advantage of the general network effects of being part of the NIM ecosystem. And like I said at the beginning, I'm the DevRel officer. So for developers, NIM has basically taken a shift now. We launched mainnet yesterday, as I've said. So now we've been really focused on infrastructure for the past year or so. Now we want to get people building. We want to get people using these applications. Our grant program is going to be rolling out soon. So if building on NIM sounds interesting to you, keep your eyes peeled for that. Also get in touch with me. Oh, and I finished my last point as well. Get in touch. So I'm Max at nimtech.net. I'll be around. I'm also in our Keybase and Discord. So reach out.
Thank you very much, Max. Do we have any questions? I actually don't see. Oh, yeah, the box.
Oh, it does. Yes, it does. Hey, thanks a lot for the presentation and the work that you guys have been up to. So I actually have a question with regards to the credential scheme, you've already mentioned that verification on Ethereum is pretty expensive. I wonder how does the proof generation looks like in terms of efficiency and how practical it is to generate those proofs on constrained mobile devices, etc.
So on mobile devices, well, the proof of concept that we did for the COVID passport, that was actually building everything on a phone. So very little latency is all I say. It's very usable, even at this kind of like POC level. If you're doing this in a desktop setting, then you shouldn't really notice too much lag with the actual, the initial ZK proof that you're using to facilitate the blind signing when you actually ask the validator set to create this credential for you. There's very little latency there.
Cool, thanks.
I think it's actually time. I want to say congrats. You just launched yesterday.
Yeah, thanks.
Congrats, Nim.
Apologies for being slightly frazzled because of that.
No problem.
Yeah.